Have you ever just stopped and wondered how you can book a flight, order a pizza, and check the weather all from different apps on your phone, and it all happens in just a few seconds? Well, there's a hidden engine powering almost everything you do online. It's kind of the unsung hero of our connected world. And in this explainer, we're going to pull back the curtain on that secret engine and demystify the API.
So let's just dive right in. How does a travel app get flight info from a dozen different airlines, like instantly? Or how does your food delivery app know exactly which restaurants are open and what's on the menu? The answer to all of this is in how these totally separate pieces of software actually talk to each other.
To really get our heads around this, we're going to start with a really simple, but honestly, a super powerful analogy that makes this whole techie concept feel instantly familiar. Let's think of an API as a kind of universal waiter.
Okay, yeah, the formal name, Application Programming Interface, or API, sounds a bit complicated, but the core idea is so much simpler. The best way to think about an API is just as a messenger. It doesn't actually own the data, and it doesn't do the task itself. It just carries messages back and forth between the systems that do.
So imagine you're sitting in a restaurant. You are the user, and the kitchen in the back, that's the system that's going to prepare your order. The API is your waiter. You look at the menu and make a request. The waiter takes that request to the kitchen gets to work, and then the waiter delivers the final result right back to your table. Simple as that.
Now, let's apply that to something real, like a travel website. The website itself doesn't own any planes, right? It uses an airline's API, the waiter, to ask their system for information on seats and prices. That API then grabs the airline's response and delivers it straight back to the travel site, which then shows it to you. That is how this whole engine of connectivity really works.
Okay, but for all these different waiters and kitchens to understand each other without total chaos, they need a shared set of rules. They've got to be speaking the same language.
And a very, very common style for these rules is something called REST. Now, don't think of REST as a super strict language. It's more like a set of agreed-upon guidelines that makes all this communication predictable. A key part of this is using common HTTP methods, which people often just call verbs, to tell the system what kind of action you want it to perform.
For example, let's look at 3 common commands that can be a little confusing: post, put, and patch. Post is when you want to create something brand new, like posting a new photo online. Put completely replaces something that's already there, like uploading a totally new profile picture. And patch? That's for a partial update, like if you just want to change your username without touching the rest of your profile.
So now that we have the rules of the road, let's look at the actual conversation itself. Every single API interaction is a 2-part dialogue. You've got a request coming from the client, and then a response coming back from the server.
A request has 5 core parts. First up is the method. That's the verb we just talked about, like get to go grab some data. Then you have the URI, which is just the specific address for what you want. You've also got the HTTP version, the request header, which has important little details, and finally, the request body. That's where you put the actual data you're sending.
And that data inside the request body has a specific name. It's called the payload. But don't let the name throw you. Simply put, the payload is just the content of the message. If you're posting a comment, the actual text of that comment is the payload.
Then, on the flip side, we get the response back from the server. It's structured pretty similarly, but it adds a super important piece of feedback: the status code. This tells you exactly what happened. You've probably seen a 404 not found error before, right? Well, a successful request gets a code in the 200s. That code, plus the data you asked for in the response body, is what completes the whole conversation.
So we get the conversation. But in a world that demands instant results, a slow conversation is just frustrating. So the next logical question is, how do you make all this work fast? How do you go from something that just works to something that's truly efficient?
But hold on. Before we start tweaking things, here's a really critical piece of advice from ByteByteGo. See, optimization can add a lot of complexity, so you shouldn't just start changing things randomly. The first and most important step is to test your system and find the actual bottlenecks. Don't guess where the slowdown is, you gotta prove it.
Okay, with that in mind, here are 4 pro tips for speeding things up. First, caching. This just means storing results you use all the time so you don't have to fetch them over and over. Second, connection pooling. Instead of the slow process of opening and closing database connections for every single request, you just reuse existing ones from a pool. Third, pagination. If a request asks for 1 million things, don't send them all at once. Break them up into smaller, manageable pages.
And finally, compression. You just shrink the size of the data so it can travel way faster across the network.
Speed is one thing, but a truly great API is also predictable, it's reliable, and it's easy for other developers to use. So for our final section, let's look at the best practices that really separate a good API from a truly great one.
Now, a core principle here is this idea of idempotency. Okay, it's a bit of a mouthful, but an idempotent method is one that has the exact same effect no matter how many times you call it. Think about pressing an elevator button. You press it once, the light goes on. You press it 10 more times, the light just stays on. It doesn't call 10 more elevators. That predictability is absolutely crucial for building reliable systems.
So when you put it all together, modern API developers kind of follow a checklist like this one. They use common data formats like JSON, they communicate results clearly with the right status codes, they design logical addresses for their resources, and of course, they build in security from the very, very beginning. It's all about creating a reliable and predictable experience for everyone.
From the weather app on your phone, to the map that guides you to a new restaurant, to the payment you make with just a tap, APIs are those invisible messengers making it all possible. They really are the true engine of our connected world. Which kind of makes you wonder, what unsung APIs are powering your day right now?